Hello and welcome to this screencast which explains how to calculate the double bond equivalence of a molecule from its molecular formula. It's useful to calculate the double bond equivalence of a molecule because it can tell us how many rings and/or double bonds are within a molecule, or indicate whether the molecule is aromatic. This is useful information when trying to work out the structure of an unknown molecule, for example using NMR spectra. To work out the degree of unsaturation of a compound, we need to compare it to its corresponding fully saturated version, in other words, its corresponding alkane. Alkanes are the simplest fully saturated molecules, and they have the general formula of CnH2n+2. The presence of rings or double bonds in a molecule will reduce the proportion of hydrogen atoms relative to carbons compared with the corresponding alkane. Let's look at an example. This is butane, an alkane with a molecular formula C4H10. This formula agrees with the general formula for an alkane, CnH2n+2. If we add a double bond to butane to make buteene, then we have to lose 2 hydrogen atoms to maintain the octet rule. So for every double bond we add, we lose 2 hydrogen atoms relative to the corresponding alkane. The same principle applies with rings. If you think of joining together the ends of a straight chain alkane to make a cycloalkane, you need to lose 2 hydrogen atoms to form the carbon-carbon bond. We can calculate how short of hydrogen atoms a molecule is compared with its corresponding alkane, and therefore determine its degree of unsaturation. In this first example, the molecule contains 10 carbon atoms. The alkane with 10 carbon atoms in would have 22 hydrogen atoms, but this molecule only has 16. This means that the molecule is 6 hydrogens short of full saturation. To calculate the double bond equivalence of this molecule, we need to divide the number of missing hydrogen atoms by 2, since we lose 2 for every double bond as we saw before. Therefore, this molecule has 3 double bond equivalents. In molecules which contain elements other than carbon and hydrogen, we must replace the heteroatoms with hydrocarbon groups of equivalent valency. Halogens, such as chlorine, join to the rest of the molecule via one bond, so can be replaced with a hydrocarbon group which also attaches to molecules via one bond, in this case a methyl group. An oxygen atom attaches to molecules via 2 bonds, and so can be replaced with a CH2 group. A nitrogen atom attaches to molecules via 3 bonds, and should be replaced with a CH group. Let's look at an example of a molecule containing a heteroatom. In this case, we need to replace the nitrogen with a CH group, giving us an equivalent molecular formula of C6H6. An alkane containing 6 carbons would have 14 hydrogen atoms, so this molecule is 8 hydrogen atoms short of full saturation. The number of double bond equivalents is therefore 4. Here are some more practice questions. The answers are shown on the next slide, so you might want to pause the screencast while you have a go. Thanks for watching, and look out for more resources coming soon on the Analytical Science Tutor channel.